morning. Today's warm-up was designed to push you a little bit, challenge you, and to also incorporate ideas from the recent past and from the distant past. So give me a thumbs up if you have any answer at all. Thumbs up if you have an answer. I've got 1, 2, 3. Okay? So, give me your answer. Chris, Dalton, and then Davis. What's your answer? 20. Okay. I'm sorry? 14. So we've got 3 different proposals. Any others? Okay, I will say that none of those are correct. And the correct answer is... I'm not going to reveal the answer. You already knew that, though. So you can see that my other group, I have 4 students who did figure it out already. So I'm throwing down the gauntlet. Bonus points towards your classwork homework grade for the first 5 students who are able to tell me the correct answer and support it with some sort of evidence. It's not a guessing game. So there was a student who figured it out, kind of not the most appropriate approach, didn't really support the answer, asked the person to go back, try again, and they were able to actually support it with real concrete evidence. Okay? So you could figure it out in the next 2 minutes, you could figure it out in an hour, you could figure it out in a day. I will leave it open until the end of the week. As long as there are spots available, you may try to put yourself into one of those spots. Okay? Any questions? All right. Diagram with an inscribed angle. Something that's inscribed in a circle means that each of the vertices is on the circle. So angle DEF is inscribed because of this, this, and this. What I would focus on for the purposes of today is that the vertex is on the circle. That is key. Because what you learned up till today was a central angle. And we learned that central angles are like this. So that still exists as an idea that we're going to be using. And now we're going to add in the idea of an inscribed angle. Central angle, inscribed angle. The idea of intercepted arc is still the same. Arc DF is the intercepted arc of that inscribed angle. When you inscribe an angle in a circle, there are 3 different possible ways it could be constructed. One leg of the angle could go through, could be the diameter, and then there would be another leg which would be a chord. You could have 2 chords, as in case 2, and then the center of the circle would be on the interior of the angle. Or you could have 2 chords, as in case 3, and the center of the circle is on the exterior of the angle. 3 different possibilities. Any questions so far on what an inscribed angle is? Now the theorems and the ideas that utilize them. First of all, if you will find the first one, which I originally put measure of an inscribed angle theorem. You can cross out measure of an. We're just going to call it the inscribed angle theorem. I actually think that I didn't mean to put that. And this is a critical idea. The measure of an inscribed angle is half of the measure of its arc. So angle D will be half the measure of this arc, as written out here using symbols. By contrast, you learned that a central angle will have the same measure as its arc. So this angle, I don't know, maybe that's 110, would be the same as this arc. That would also be 110. But this inscribed angle would be half of the arc. So if this was 110, this would be 55. So there is a relationship. Any questions about that? And we're going to utilize this all today and add it to our toolbox of tools that we can use to solve problems. Any questions? Good. The second theorem is the congruent inscribed angles theorem. If you have two inscribed angles that have the same intercepted arc, then the two angles must be congruent to each other. So to clarify what we're looking at, if we look at ADC, that is intercepting arc AB, and then we have angle ACB, that is also intercepting the same arc right here. They are both intercepting that arc. Two inscribed angles intercepting the same arc, they are congruent to each other. Any questions about just the wording and the basics? Again, we're going to utilize this idea to solve problems, another tool in our toolbox. Now inscribed polygons, two that we're going to explore today. The inscribed right triangle theorem. If you have a triangle inscribed in a circle and the hypotenuse is the diameter, then the triangle must be a right triangle. The converse is also true. If you have a right triangle inscribed in a circle, then the hypotenuse must be a diameter. You can see it written as a biconditional. You can see it written as a biconditional right here. Okay? Any questions about the inscribed right triangle theorem? Again, don't worry about the name. Just worry about the idea. And then lastly, the inscribed quadrilateral. If you have a quadrilateral inscribed inside a circle, its opposite angles will be supplementary. And this also is biconditional, meaning it works in reverse as well. Let me first clarify what is meant by opposite angles. Angle D and angle F are opposite, and angle E and angle G are opposite, which means their angles will be supplementary. So this angle and this angle will be supplementary, and this angle will be supplementary. So, if we have a quadrilateral inscribed in a circle, then the opposite angles are supplementary. If we want to see if a quadrilateral could be inscribed in a circle, then we check to see if the opposite angles are supplementary, and then we could say that it would be able to be inscribed in a circle. Okay? So, this is just an overview, so let's go ahead and get started. Any questions before we jump in? All right. Example 1. So, we're going to start out with a sketch of the picture. I did not give compasses on purpose because I wanted just a sketch is going to be sufficient for now. Don't make a mess of a circle. Try to do a decent circle, and if you have graph paper, it's not too hard. And just the idea is we're going by the numbers. We're not going by a perfect picture. And what we're going to do today is we're going to build to a challenge. And so some of the questions are going to seem a little bit easier, but the idea is to build to the challenge at the end, towards the end. Actually, a couple of challenges towards the end. So again, I'm just giving you a moment to sketch the picture. I noticed some of you, and in the other class as well, draw very small pictures. One thing that you're going to need to start to understand is that frequently we're going to add something to the pictures. And so if you make your picture tiny and you make it difficult to add details to it, so be free with the space on your paper. Draw a bigger picture. All right, so let's just get the inscribed angles theorem down pat. I would like in part A to find the measure of PRU. Give me a thumbs up if you already know it. A couple people already know it. Maria, what is it?
I would believe 118 degrees.
Okay, so it's not 118 degrees because it would have to be a central angle to be 118 degrees. This is an inscribed angle. That's okay, we're just learning now, so that's the whole point of this. Zabari? Okay, so this is going to be 59 degrees because the relationship is that the angle is half of the arc. So this angle here is going to be half the measure of arc PU. So you take the measure of the arc, cut it in half, and you get the measure of the angle. So if we could say that the angle is half of the arc, what would you say in words if, as in part B, I asked for the arc and you had the angle? Alicia, what would you say in words? If the angle is half of the arc, what would you say if you had to go in the other direction? Beautifully said. The arc is going to be twice the angle, and so arc SP will be what, Alicia? I'm sorry? 54 degrees. Very good. So, does anyone have any questions about the basics? Any questions or concerns? Okay. Checkpoint number 1. Elevating the level a little bit. You do not need to draw anything. Just answer question A, answer question B. You got 2 minutes. And if you're done before the bell rings, compare your answers with your new teammates to see if you guys agree. Of course, if you need any guidance, please let me know. Very well said. All right. Please make a note of your new desk number. And let's see how we did. Part A, what did you get for the measure of arc ADC? I got student 2, student 5, and student 17. Student number 2. Okay, student number 5. Student 17. Okay, so we have one student who got it. 270 degrees. And I'm going to come back to you in a moment. Part B, measure of angle DAE. I've got student 12, student 6, and student 15. Student number 12.
38 degrees.
Student number 6.
38 degrees.
Student number 15.
38 degrees.
So in that case, more people were able to deal with that, so that is a 38-degree angle. So part B was, I guess, a little bit easier, but let's go to Anne. Out of my 3 students I called on, you seem to have success. How did you figure out the 270? That is correct. That is the simplest route to the answer. It's not the only route. Arc ADC is a major arc from here to here, going all the way around here. Which means that its measurement will be made up of, and let me see if this works, this here and here, that angle right there, which is a measure of 135 degrees. As Alicia defined for us, the measure of the arc will be twice the measure of the angle if it's an inscribed angle. This is inscribed because the vertex and the 2 endpoints are on the circle. Very nicely done. Any comments, questions? Alicia.
I understand that now, but I got it wrong because before I did A to D and then C.
Okay, so what is the measure of A to D? Of arc AD? Yeah, it's 180. Well, I guess we don't know. If we assume that that's a semicircle, maybe it is, but it's very difficult to tell because we don't really have enough information. So you really had to go with what you had, and the key was this right here. Okay? But I understand your approach. Any comments, questions? Kassar, do you see it now? Danielle, you see it now? Good. Any observations or concerns? All right? So now, congruent inscribed angles theorem. If you have 2 inscribed angles that have the same intercepted arc, then the 2 angles are congruent to each other. So, example 2, a sketch of the picture. And please make the picture a decent size because you're going to be filling in a whole bunch of different details. Our task in example 2 is to find the measures of all the arcs and all the angles. And I would like you to, at some point, use the congruent inscribed angles theorem, although you don't have to. There are actually a bunch of different ways to get all the details of this diagram. So here's what we're going to do for this one. We're going to use this as a quick little team activity. And I'm going to give you 2 minutes. And I want you to find me as many measures of angles and arcs that you can. You don't have to find all of them. We're going to find them all together as a whole group. But you should be able to find quite a few. So, I'm sorry, let me give another moment to go ahead and finish the picture. Yeah.
What would you call, can we just put a random line in the middle?
Oh, yeah, it's my mistake. So let me, I didn't assign a letter to the middle. So let's call that,
Q, E.
we'll call it S. So the center will be S. And yeah, that was actually important, and that was my bad. So thank you for pointing that out. That did come up earlier, and I forgot to put it back in. All right, so I'm going to restart the clock. You got 2 minutes with your team. If you find a piece of information, share it with your team. Don't let one person monopolize the entire conversation. See what you can figure out, and make sure you can explain where the idea or detail comes from. You got a minute. Find as many measures that you can. Doesn't have to be all of them, although that is our goal as a group.
I know angle S.
Every angle, every arc. Okay, make a note of your new team letter if you are on a new team. And remember, you did not have to get all of them, but now as a whole group, we're going to fill in everything. Team C, student number 9, what did your team find? Give me one detail. Arc BC, DC is 116. That is absolutely correct. Very nicely done. Team B, student number 5. Give me something that your team discovered. Arc BC is 64 degrees. That is correct. How did you prove that? Catalina, how did you prove it?
Because since you can see that it's like a linear pair, kind of, you see where I'm
Use letters to tell.
S is,
Yeah.
116 and the line. You can see that if you did 180 minus 116, it's 64.
Very good. Can someone explain why arc BC is 64 a different way? Explain it a different way, Shelby. Okay, very good. Can someone explain it yet another way? Zavari.
Because the inscribed angle SDC is 70 degrees, so most likely
Very good. So the inscribed angles theorem, right here, the 32 degrees, double it, you get the 64 degrees. But we got 3 different explanations, and we could probably have more. Very good. But I need to move on to make sure I cover everything today. Give you another detail that your team discovered. Team A, student number 2. AD, arc AD is 64 degrees. Absolutely. Very good. Team H, student number 24. What did you, give me another detail. Angle BSC is 64 degrees. Very good. Team F, student number 16. Give me another detail.
Angle B, arc AB is 116 degrees.
That is correct. Arc AB is 116 degrees. Team B, student number 4. Give me another detail.
Angle SCD is 32 degrees.
Very good. Arc SCD is 32 degrees. How did you figure that out?
Because the triangle is 90 degrees and I did that. And also now that I learned, you can do 64 divided by 2.
That's right. So she proved it 2 ways. The triangle sum theorem, 32, 116, this would have to be 32. And now you can also confirm it with the 64, the arc right here. You cut it in half and you get that angle right there. Beautifully explained. Team F, student number 18. ASD is 64 degrees. Very good. How could you prove it? Beautiful. Vertical angles. Team A, student number 1, give me another detail.
ABC is 180. The arc ABC
ABC
is 180.
is 180 degrees. Very good. Team G, student number 20, give me another detail. Beautifully done. SBA is 32 degrees. Why? Inscribed angles theorem. Could someone give me another reason why? Chris? Triangle sum theorem, okay. Well, I don't have this angle and I don't have that angle, so I'm not sure how I use the triangle sum theorem. Oh, you have them, okay. Good. Based on my picture here, what's another way we could do it? Maria?
I think it was interior angle. No, wait. They're congruent in described angles.
Yeah, congruent inscribed angles theorem. These two angles, ABD and ACD, are both intercepting the same arc, which means this must be congruent to this. That's another way to prove it. Everything that was said already is true. What Chris said was true as well. Okay, yes, Dalton. Okay, good. So there's actually a lot going on in this picture. There's actually more that we could add in that has nothing to do with arcs and angles. Can someone provide a new detail to the picture that has nothing to do with arcs and angles? Catalina and then Chris.
The circle is 360 degrees.
Circle's 360 degrees. Chris.
Chord AB is parallel to chord DC.
Very nicely figured out. That is parallel to that. Why?
Because the interior angles converse.
That's right. Alternate interior angles converse. If this angle is congruent to this angle, then the two lines must be parallel. Very good. Ania. Very good. DB is a diameter. What else could you tell us? Anne.
I'm not sure, but can we assume that the two triangles are
I don't know. Can we? It's not an assumption. Can you prove it? So we're missing something in the picture that I could add, but you need to be able to explain why, that we could then conclude hers. Danielle? Okay, so we could add in this angle here. But what about something that has nothing to do with angles and arcs? You're absolutely right, Daniela. Michaela?
SC is the radius.
SC is the radius. Is that it? Dalton?
They're both isosceles triangles.
They are both isosceles triangles. Very good, which means this must be congruent to that. Oh, and that is congruent to that. Why are they all congruent? They're all radii. They're all radii. So, Anne, can we prove your idea? Yes, these two triangles are congruent. So there's a lot going on in this picture. Very good. Does anyone have any concerns, questions, or theories? Good. Let's see how you do with checkpoint number 2. Very different question. You got 2 minutes. Compare your answers to your teammates once you have figured it out. You do not need to draw anything. right, we're back as a whole group. Let's see how we did with checkpoint 2. I've got student 9, 15, and 10. Student number 9, what'd you get? Student number 15.
7.
Student number 10. So 3 of my students think the answer is 7. The answer is 7. Does anyone have any concerns? So we went from a task that took a little more time, a little more involved, and then I put it down into a simpler task. But it was all about the relationship. These 2 angles are both intercepting the same arc, which means the 2 angles are congruent to each other. Give me a thumbs up if you got that correct. Good. Concern? Okay. So now, the last 2 ideas. What happens when we inscribe a polygon inside a circle? The inscribed right triangle theorem and the inscribed quadrilateral theorem. If the hypotenuse is a diameter, then the triangle must be a right triangle. Conversely, if it's a right triangle inscribed in a circle, then this must be the diameter. The inscribed quadrilateral theorem. Opposite angles are supplementary, so we talked about these being opposites. So let's go ahead and utilize these ideas to solve some problems. Do not sketch the picture for this one. I don't think there's any value in the time spent on that. Or there's not as much value. So we're just going to use the picture up here. Find the angle measures of G, H, J, and K. So I would like to be able to list the measure of angle G, measure of angle H, measure of angle J, and the measure of angle K. This is a quadrilateral. GHJK is a quadrilateral inscribed in a circle. We can see it. Each vertex is a point on the circle. Because of that, we know that there's a relationship that exists. J and G must be supplementary, which means that this algebraic expression and this algebraic expression together must add up to 180. So because of that relationship, we can set up something to find missing pieces, and then from there, things snowball. So if we've got 6b plus 20, and we add 3b plus 25, that must equal 180 because we know that those 2 angles must be supplementary. So now we can solve for b. Go ahead and solve for b. Give me a thumbs up when you got it. 1, 2, 3, 4, 5, 6, 7. Put your thumbs down. Kayla, what does b come out to? Comes out to 15. And now we can take that value and plug it into each expression, or we can use the relationships based on the fact that this is a quadrilateral inscribed in a circle. In other words, once we know G, we can find J because they're supplementary, and once we know K, we can find H because they're supplementary. Let's go ahead and start with G. What's the value? What is the measure of G, Anit? It is 70 degrees, which means that we can find J by subtracting that value from 180, and we know immediately that that's going to be 110 degrees. What about angle K? What does K come out to? Raquel?
81 degrees.
Comes out to, is it 81? Is that right? Okay. 81 degrees. And because that is supplementary with angle H, we can subtract that from 180 and we get 99 degrees. And so we are able to get all the measures. Any questions on how we did that, Alicia? 70 and 110 is 180. 81 and 99 is 180. 180 and 180 is 360. Okay. Maybe you're typing something wrong. It's okay. I'll come work with you. Example 4. What about the inscribed right triangle theorem? And again, you don't need to draw the picture. You don't need to sketch the picture this time. There is value in it, but time-wise, I'd rather spend the time just focused. So, if you have a triangle inscribed in a circle, and you can see it because the vertices are all points on the circle, and the hypotenuse is the diameter of the circle, which we can see visually. It's shown, bless you, that the center of the circle is right here. This is a chord going through the center. That is a diameter. Then we immediately know that this must be a right angle. That must be a right angle. Because of that, we can set up relationships to solve for what we need. In this question, we're asked again for the value of x. So we know based on the triangle sum theorem that the 3 angles in a triangle add up to. There's also a corollary to that theorem that if it's a right triangle, the 2 non-right angles will add up to 90. So we can set up 1/2 x, which is angle A, plus 1/3 x plus 5 must equal 90 degrees. And we can solve for x. That's really 3/6, that's 2/6, this is really 5/6 x plus 5 equals 90. Solve for x. Give me a thumbs up when you've got x. 1, 2, 3, 4, 5, 6, 7, 8. Okay, put your thumbs down. I don't want to spend time struggling because of the 5/6 or anything like that. So Chris, what does x come out to? Comes out to 102. Very good. And that's what we were asked for, so that's it. Any questions about that? So, it started out by understanding that because of the inscribed triangle and the fact that the hypotenuse is the diameter, that we can establish that that is a 90-degree angle. Any concerns about that? All right, checkpoint number 3. Find me the measure of angle OBC. Measure of OBC, and you've got 2 minutes. measure of angle OBC? I've got student 21, 24, and 10. Student 21, what'd you get? Student 24. Student number 10. So I've got two students who think it's 62 degrees. It is 62 degrees. So, where's the logic? Where's the logic? We'll start with Catalina, and then Daniela, and then Zabari.
Well, first I saw that it's a right triangle inside.
Okay, so that is a key. This has to be a right triangle because it's an inscribed triangle, and this is the diameter, the hypotenuse. So you need to have that detail. Good. Daniela, what else? Well, you were, but I guess you didn't intend to? Okay. Zabari.
I just realized it, but you have to see.
Yeah. This is a radius. And you said OB and what? That's a radius. OA is a radius. That's the key right there. So what is the measure of angle ABO? What's the measure of angle ABO? Alicia? Why? Kayla? Very good. You said that beautifully. It's the base angles theorem. Isosceles triangle, the base angles are going to be congruent. And because of what Catalina pointed out, that this is a 90-degree angle, and that's 28, you can easily find OBC by subtracting 28 from 90.
I did it.
Yeah, there's quite a few different ways to do it. Go ahead.
I saw with the congruent inscribed angles theorem, I saw BAC and BOC.
BAC and BOC, okay.
So I found the angle of BOC because it's 28 times 2.
Very good. So this arc. Oh, so these are congruent to each other?
No.
No.
No, but 28 times 2 is angle BOC.
That's right. So this is going to be 56, this arc. And that means this angle, since it's a central angle, is going to be 56 degrees as well. And from there you can figure some things out. Very good. Excellent job. Now, we were going to finish out, so that was one challenge. And then we're going to finish out with a team challenge. Team leaders, you have a diagram. If you would please pass one to each member of your team. And we're going to just get started. This is supposed to be about a 10-minute activity, maybe about 8 to 10 minutes. We don't have that time, so I apologize for that. But we'll get started and see how far you can get. You need to make sure you read this statement here. And then I would like you to find me the measure of angle AEB and the measure of arc DE. So unfortunately, we only have a couple of minutes to do this. So go ahead and see what you can figure out. And of course, I'll be around for guidance. Remember, the answer is not important, it's the process that's important. And I gave you a copy of the diagram so you would mark it up and draw on it, etc., etc. Yes. Yes. Angle ABC is 132 degrees. Good. I love how I see people already putting in details right away. Very good. Also says it right there in the text. see it on the paper, if you see it on the diagram, it might help spark something. Okay, so I apologize. That certainly was not intended. I'm not going to reveal the answers because I want to give my students a chance to wrestle with the questions and to try and work their way through it. Also remember that there is still the possibility of bonus points for getting today's warm-up. Nobody from this class has shown me correct answer yet. But I will give you these answers tomorrow when I see you, okay? So, your homework is on page 666, numbers 6 through 18. Then you are doing numbers 27 and 38, and they are in bold because those are the more challenging questions that are going to require your time. Do the at-home tutor for 10.5 or read the next section. And you'll have a quiz on 10.1 to 10.4 on Thursday.